All right, this will be a walkthrough demo video for constructing a Z confidence interval for population proportion in Desmos. So we have a question over here. The context is just some generic survey. We surveyed 215 people, found that 60 responded yes to the survey question, and we want a 92% confidence interval to estimate the proportion of the population that would answer yes. So over here in Desmos, I need to access my inference tools, which I can do from a couple of different ways. I can go up to the plus add item and select inference from there, or I can just type the word inference in a line on the calculator. That brings up the inference tools menu. So here we're going to be doing a Z confidence interval for a proportion. That's inference for categorical data. And all of the inference tools are labeled according to the hypothesis test, but we can do either the hypothesis test or the confidence interval. So we're going to select Z test for proportions. And then that brings up the screen for me to enter the information I need to give Desmos in order for it to construct my confidence interval. So all it needs for a confidence interval for a proportion is the number of successes. So I go to my problem, I see 60 responded yes to my survey. So that's my number of successes. And I need my sample size, and I see that 215 were surveyed. So that's what I need to enter, and then I click Create Test. Notice when I do that, first of all, it shows me the syntax for this tool is zprop test, and then inside the function, successes and sample size. So I could have just typed that into a line in the calculator if you're comfortable with that syntax, but you can always use the tools from the menu. We're only interested here in the confidence interval, so I'm going to drop open the confidence interval section. And the first thing I have to do is check my confidence level. The default is always 0.95, but here I want a 92% confidence interval. So I'm going to enter 0.92 for my confidence level. We always put it in as a decimal. And so when I do that, it adjusts down here and it shows me my lower bound and my upper bound to 3 decimal places. And if I hover over that dot in the middle, it shows me my point estimate, which is the p hat that Desmos computed from the information I gave it. So that's just 60 divided by 215. I don't have to compute that. It's part of the results that I get here. If I need any of the values from the inference to more decimal places, or if I want to see, for example, the standard error, I can just click on the 3-dot menu and it gives me all of these to 5 decimal places, or I can get even more decimal places by exporting the value into a new line in the graph. So for example, here's my p hat. The estimate value up here, I see it's 0.279, but here I get more decimal places. And if I need to use one of these values in some other computation, once I have it in a line like this, I can just give it a variable name. And then that way I'm going to have no rounding error when I use this for something else. But for this problem, I just need the lower and upper bound to 3 decimal places. So I can see that from the main results. So I enter 0.226 for the lower bound, 0.333 for the upper bound. And I'm also asked in this problem to include the population parameter in this between inequality notation. So since we are estimating the population proportion, the parameter that we're estimating in that case is P. So I'm going to select the P from the parameter list, and that gives me the complete confidence interval.